So we see we can either reach a high concentration of methane in our clean biogas or a high amount of clean biogas, but not both. And furthermore, we cannot even reach the required specification for biomethane in order to feed it to the natural gas grid, which is at 98% over here. So what do we have to do? Well, one simple equilibrium stage is not enough, so we have to use a scrubber column instead. We'll do this here, so we have to modify our flow sheet. I will remove the flash, so clicking on it, pressing delete, and it is gone. And I will select a different unit op which can help us here, which is the CDS column. But I don't want to have a distillation column. So using the right click here on this, I can select at least the sketch of a simple scrubber column. I have to reorganize my streams a bit. So I reconnect everything again. And then the clean biogas has to be connected. And now I don't have just one single equilibrium stage, but here in this unit operation, I can put several equilibrium stages. So here I will work with a top pressure of 10 bar. Let's start with 10 stages that we have. The feed stage of stream 1, which is the water, goes to the top, which is stage 1, and the raw biogas goes to stage 10. Now we are running with the before optimal thing, so 110, almost 110 cubic meters of water, having a temperature of 20 degrees Celsius now, and the pressure in the column is 10 bar. So let's go back to the home screen. Be careful, don't press here on this analysis screen the run button. This might be confusing, but if you do this, the optimization will start again. So be sure to go back to the home screen, or instead you can also use the small run all button, which is here on the top line. Okay, so run all. Yes, we have again the warning with the pressure, because the water pressure is not high enough and the gas pressure is not high enough to enter the column with 10 bar. But well, let's ignore this for the moment. And we see now we have here 90% of methane and a much higher biogas stream. So this is almost all methane moving to the top. So again, we can play with our parameters, but now we added an additional parameter. So what are our 4 parameters for optimization now? We have the water, the amount of water. We have the temperature of the water, with which we control the temperature inside the column. We have the pressure on the column, and we have the number of stages in the column. So now we have 4 optimization parameters, and we can try to redo our optimization now. But let's first see how we can reach these 98% of biomethane now. So I will play a bit my parameters by hand. So I will reduce the temperature. Let's see what happens. With 5 degrees Celsius of our scrubbing water, now we easily reach the 98%. We even have 99.9%. So this is too much. So now we can try to reduce our other parameters. We will have a look in how to optimize these, because finally in the optimization of a plant, it is important how much do we have to pay for each parameter. So we have to pay for the water, of course, that we use for scrubbing. We have to pay for the temperature, because we will need some cooling machines to cool down the water. We will have to pay for the pressure, because we have to compress our biogas and, of course, to pump our water. And we have to pay for the column itself, because the more theoretical stages I have inside, the higher the column will become. So these costs will also increase. We have to address these points. But with this scrubbing column, we can see that we can easily reach at least the requirements, 99.9% without any issue. So we can reduce some parameters to get the 98% of biomethane concentration. We can look into the column to see if it is sized well. So here are the results. With the right click, we can plot our profiles. So we can plot the column profile here. And I would like to see the vapor phase and the amount of methane, so the mole fraction of methane in our column, so we can see at which stage we reach our 98%. We can see this here, so this is where we enter, and this is the first equilibrium stage, so we enter with 50% of methane, and then the methane amount inside the column increases. And we see here, like after some stages, around 5 stages, we have reached the 98%, 99%, and we see here the additional stages that we have don't increase the methane concentration much. So from this point, I can see my column has sufficient stages. We can even reduce the number of stages to save some investment costs. So we look at this economical optimization later. But these are the preliminary results, and we can find out, yes, we can produce biomethane in our plant.